This presentation is on understanding the t-distribution for the purposes of calculating a t-test. The t-test, as we will discover, is far more applicable to everyday statistical analysis than is the z-test. The following presentations will cover t-test calculation. The story of the discovery of the t-test is an interesting one and should help us to better understand its usefulness. The story begins in Dublin, Ireland, where the Guinness Brewery brews its famous beer. A statistician employed by Guinness, William Gossett, needed a way to determine if a sample of beer was likely to be skunked or unsuitable for drinking. The normal distribution was not up to the task because the samples he was working with were small samples, much less than the 30 samples required for the central limit theorem to be invoked. Instead, Gossett had the following insight. The sampling distribution has interesting properties the larger the sample gets. In fact, the sampling distributions are very predictable. When the sample sizes are very small, the tails, or ends of the distribution, are very large in comparison to the small middle, or hump, of the distribution. These are called t-distributions. Observe these several slides in sequence. The tails get smaller and the hump gets larger as the sample size increases. These are obviously freehand drawings. Notice that 95% of all observations in these t-distributions reach different standard deviation values away from the mean than in the normal distribution. With the normal distribution, 95% of all observations lie within 2 standard deviation units from the mean value, always. But notice that if the sample size, or n, is equal to 5, then 95% of all observations are within 2.776 standard deviation units from the mean value. So in all likelihood, there are more extreme values than in the normally distributed variable, where 95% of all observations are within 2 standard deviation units of the mean value. The values become potentially less and less extreme as the sample size increases. In the sample size, or n equals 10, 95% of all observations are within 2.262 standard deviation units from the mean value. The extreme values are closer to 2 standard deviation units, but not quite there. In the sample size, or n equals 20, 95% of all observations are within 2.086 units, standard deviation units, of the mean value. And in the sample size, or n equals 30, of course, 95% of all observations are within 2.04 standard deviation units of the mean, or in rounding terms, 2 standard deviation units from the mean value. Gossett had an additional insight other than the shape of the t-distribution changing based on the size of the sample. By altering the formula for the z-test slightly, we could capture the changing distributional shape so that we can test whether or not to accept the null hypothesis for samples of data, as opposed to needing information about the population, as was required by the z-test. We recall that acquiring population information is nearly impossible in practical terms, but we always have access to information about samples of data. The formula is as follows. The t-test is equal to x bar minus mu divided by the sample standard deviation, s, further divided by the number of samples minus 1, and taking the square root of the number of samples minus 1. Thus x bar is the smaller sample mean. Mu is a larger sample mean. S is the smaller sample standard deviation. N minus 1 is the smaller sample size minus 1, after which we take the square root. We will calculate a t-test in the next presentation. Before we leave this topic, I have a little more to say about Gosset's considerable contributions to statistical analysis. Since Gosset was working for Gneiss when he made these discoveries about small samples in the t-tests, the discoveries were proprietary, or under the control of the Gneiss company, so he could not publish them on his own, as academics do in their research work. Instead, he adopted an alias, calling himself Student. So this t-test is also known as the Student's t-test in honor of Gosset. Now we can move on to calculating the t-test.